Welcome back to Outward Home Learning. The subject that we're looking at today is computer science, and the topic is bubble sorts. First off, you're going to listen to Mr. Halton tell you a bit about what bubble sorts are and how they work, and then you've got some questions and tasks to complete.
A bubble sort then. I'm just going to jump pretty much straight to this one. What I'll say beforehand is this sort is really not very efficient. Computers don't actually use bubble sorts as much as possible because, it's not the best sorting algorithm in the world. But it's a simple one, so we get to start to understand how computers can possibly sort a list of numbers. Speaking of which, here's our list of numbers, and I'm going to go over exactly how we're going to sort them. And here is our bubble, and the bubble goes around to begin with the first two numbers in the list. And I just concentrate on the bubble and I ask, okay, are those numbers in order? Is 43 and 26 in order? No, because 43 is greater than 26. So because of that, I swap the numbers round. And after the swap, the bubble moves on one, so it moves up to the next set of numbers here. 43 and 18. And the same questions asked, are they in order? No, they're not, so they need to be swapped round. And then the bubble moves up another time, 43 and 39. Are they in order? Nope, so they need to be swapped round. And then the bubble moves up again, 43 and 53. Are they in order? Yes, they are. So they can stay where they are. All right, all sorted? Well, no, actually. So we've got to the end of what is called a pass at this list with a bubble going back and forth. But that doesn't mean that the list is necessarily in order. So what needs to happen is the bubble needs to go back to the start again. And the same question is asked again. So 26 and 18, are they in order? No. Bubble moves up. 26, 39, they in order? Yes. 39, 43, yes, they're in order. And 43 and 53, yes, they're in order. Okay, fantastic. So we can see as humans that this list is now in order. But what a computer will need to do is move the bubble back to the start again and go through each number. And then it records, has it made any swaps? No, it's got to the end without making any swaps. So then it knows that the list is sorted. And that's a simple demonstration of a bubble sort. Inefficient, but effective. The list is sorted. And a reminder, this works on letters just as well as numbers. That's everything you need to know for a bubble sort.
Okay, so now we've heard about what a bubble sort is and how it works from Mr. Halton. You're going to move on and complete a task. There's two bubble sorts for you to complete on the Google sheet named bubble sort task. The first one is numbers and the second one is words, and you need to record the end of each of those passes for those. You're going to get 10 minutes to complete the question. Off you go. Okay, so that's time up. We're going to go over to Mr. Barnes to review your answers.
Okay, so let's have a little look at this bubble sort task. The task itself is self-marking, but I think it's important to go through the process as well. So with a bubble sort, you're going to compare the first two values and decide whether they need to swap to get in order. Then you're going to go on to the second and third and fourth, all the way along until you get to the end. The reason it's called a bubble sort is that each time the next biggest number bubbles to the top. So there's a way of self-checking. So let's have a go. So 103 and 23, do they need swapping? Well, they do. So I'm going to write 23 down here, and I'm going to leave 103 just floating here for now. Have I made a swap? Yes, so I'm already going to change the swaps made variable to true. Okay, so now I've got 103 here, and I'm going to check with the third value, 93. So I'm going to swap them, and 103 is just bubbling along. The next one then, I've got 64 and 103, so I'm going to swap them. Then I've got 71 and 103, so I'm going to swap them. 42 and 103, so I'm going to swap them. 88 and 103, I'm going to swap them. And then I've got 73 and 103, and I'm going to swap them. Notice how 103 is the biggest number, and at the end of the first pass, it's bubbled along to the top. And then we repeat the process because a swap has been made. So if we're a computer, we've got this variable here which allows us to keep track of whether a swap has actually happened, because computers can't just look at a set of numbers and understand whether a swap's been made. Okay, so I'm going to go again. 23 and 93. Well, no, they're fine, so I'm going to write 23 down. 93 and 64. Well, they need to swap. Then I've got 93 here and 71, so they're going to swap. 42 and 93, they need to swap. 88 and 93, well, they need to swap. 73 and 93, and they need to swap. Notice how, although there's lower numbers further down that aren't in order, you keep moving along comparing the next values, and notice now that the second biggest number, 93, has gone to the top. Have we made a swap? Yes, we have, so I'm going to write true there. Okay, and we repeat the process. 23 and 64, fine. 64 and 71, fine. 71 and 42, well, we need to swap them. 71 and 88, well, that's fine, so we write 71. 88 and 73, well, they need swapping. And then the rest don't need swapping. Have we made a swap? Yes, so it's true. And then we go again, 23 and 64, that's fine, so I'm going to write 23. 64 and 42, well, they need swapping. 64 and 71, well, they're fine. 71 and 73, and then all the rest, when we compare them, are in order. But we did make a swap. At this point, we now know, looking at them as humans, that these are in order. But a computer doesn't, and because we made a swap, it looks at its variable and goes, a swap's been made, so we need to do it again. So this time, 23, 42, they're all in order, so we're not going to make any swaps. Therefore, has a swap been made? Well, that's false. And at that point, a computer knows I've gone through the entire numbers and there isn't a swap. So therefore, I'm going to stop going through and trying to sort the numbers because they're in order. Okay, let's have a look at the next one then. I'm going to be a little bit lazy with this one and not write out the full names because it'd take too long. So, words work in exactly the same way as numbers, but we're looking alphabetically this time. So, horse and novel. So I'm going to write H-O-R because there's another H in here. Novel and shake, well, that's fine. Shake and spine, well, they're fine. Spine and crash, well, they need to swap. So C-R-A-S-P-I. Okay. Oh, spine and wagon, well, they're fine. Wagon and hobby, well, they need to swap. So that's H-O-B. And then we've got wagon and uncle, and they will need to swap. Have we made a swap? Yes, we have. Okay, and we go again. So we've got horse and novel, they're still fine. So H-O-R-N-O-V. Novel and shake, well, they're still fine. Shake and crash, well, they need to swap. Shake and spine, well, they're fine. Hobby and spine, well, we need to swap them. So hob and then spine. Spine and uncle, well, they're fine. Uncle and wagon, they're fine. But once again, we've made a swap, so the computer knows to go again. So we go again. Horse and novel, they're fine. Novel and crash, well, they need to swap. Novel and shake, well, they're fine. Shake and hobby, well, they need to swap. So hob. Shake and spine, well, they're fine. And then the rest are already in order. But we've again made a swap. So then we go again. Horse and crash, well, they need to swap. Horse and novel, well, they're fine. Novel and hobby, well, they need to swap. Novel and shake, and then so on and so on, but we know the rest are already in order because they've bubbled to the top. But we've again made a swap. Next one then, crash and horse. Crash is fine. Horse and hobby, well, they need to swap. And then everything else is in order. But we have made a swap once again. So because we look at them now, they're all in order, but because we made a swap and we're a computer, we need to go, right, okay, we need to go one more time. So there's no swaps going on here, just writing them out. And this time, swaps is false, and therefore the computer will know to stop. Okay, so that variable on the end is really, really important, and if you were programming this, you'd have a variable like this which keeps track of whether another pass needs to be made.
So now you've had some practice, we're going to go and do some exam questions on bubble sorts. You've got 10 minutes to complete the questions. Mr. Barnes will review them afterwards. Off you go. And that's time up. Let's go to Mr. Barnes.
Okay, so let's have a look at this question on bubble sort and have a little walk through on how to complete the question. So here there's a Hangman program that uses a file to store the words the programmer can select from a sample data shown below. Show the stages of a bubble sort when applied to data shown in figure 3. So what it wants you to do here is it wants you to show the stages. It wants you to go through the process of completing a bubble sort. Okay, so let's do just that. Crime and bait, are they in order? No, so we're going to swap bait, and then we're going to compare crime and fright. Well, crime's before fright. Fright and victory, well, that's fine. So I'm going to write fright. Victory and nightmare, well, they're not in order, so I'm going to swap them. Okay, then we've got victory and loose, so we need to swap them. Okay, and as with all bubble sorts, the highest value bubbles to the top. And we go again. Bait and crime, that's fine. Crime and fright, that's in order. Fright and nightmare, that's in order. Loose and nightmare, well, that's not in order. So we need to swap them. And then nightmare and victory are in order. Okay. So now, bait, crime, fright, loose, nightmare, victory. Okay, so we just go again to make sure, because we did make a swap. So bait and crime's fine. Crime and fright, fine. Fright and loose, fine. Loose and nightmare, fine. And nightmare and victory. Okay. So the key thing here is, and this is where the mark scheme is interesting. The mark scheme lists every single swap that's been made. So we already swapped bait and crime. Okay, so there's one swap there. And we already swapped victory along to the end. So nightmare and fright and there and there. Okay, and we also made the swap between, I think it was loose and nightmare, wasn't it? So the key thing here is the mark scheme is quite hard to follow, but what it does say on the right hand side is one mark for each row, allow multiple swaps in one stage, which is what we've done, where it is clear that a bubble sort has been applied. So because in the first or even the second pass we made multiple swaps rather than each swap being on a new line, okay, that's absolutely fine as long as it's clear a bubble sort's been applied. And you know that's the case because each time through each pass the next highest value has ended up at the top. Therefore all 4 marks can be awarded.
Thank you for watching. That's been Bubble Sorts, and stay tuned for the next lesson.